So I just thought I would do a quick recap and a little bit extra on the inequality proofs that we did in class the other day. Basically, I want to start with these two, and then we're going to go through a couple of more complicated ones. These two, if you know how to do these well, the rest of them will come easier to you. So let's have a look at these two. We have to firstly prove that a squared plus b squared is bigger than 2ab. And then secondly, you have to prove that a minus b all squared is bigger than 4ab. Now, hopefully these look familiar to you in the fact that we're going to be using difference of two squares and perfect squares in being able to prove these. And it always comes back to the idea that something squared is always going to be bigger than or equal to 0. We're always going to come back to that idea when you see questions like this. Okay, so straight away, I want to write, if I'm just looking at this one here, I want to write that in a way that I could say something squared is bigger than 0. So I say, well, hang on, is this left-hand side the same thing? Could I say that a minus b? Now, it doesn't matter if I do minus or plus in there, you will eventually get the same result anyway. But I could say this. But then I think to myself, okay, well, hang on a second. When I expand that, I get a squared minus 2ab plus b squared. So then I can say to myself, all right, well, I can now assume that a squared plus b squared is the same thing as a minus b squared, but I have to plus on a 2ab to cancel out that minus 2ab when I expand it. Okay, now, and I would write this, we know that a minus b all squared is bigger than 0. Then we can say, well, then isn't a minus b all squared plussing with 2ab bigger than or equal to 0 plussing with 2ab? And all I've done here is taken this inequality here and plus 2ab on both sides, which you can do according to our inequality proofs. You can plus something on both sides and the inequality still stands. So now saying that, I can say, well, I know that, I'm running out of colours here, but I know now that this term here is equal to a squared plus b squared, because that's what this line here says, right? So therefore, I can say, well then, that just means that a squared plus b squared is going to be greater than or equal to 2ab. And there's my proof. Okay, so let's have a look at this one then. Let's just take the left-hand side and expand it and see what we would get. I know that if I expand that, I'm going to get this. Now, what if I look at what happens if I expanded the positive version? I know that I'd get the exact same thing, but a 2, positive 2. So, ideally, I could say that a plus b all squared is equal to a minus b all squared, apart from, if I take a plus b all squared, that would be this term here. What do I need to do to this term here to get back to this term? I'd have to subtract a 4ab. So they are equal to each other if I put in my minus 4ab here. So I take my a plus b all squared and I would subtract a 4ab, and then I would get the term up here. Or you could think about it in the other direction. I could say they are equal to each other, but I'd have to take a minus b all squared and I'd have to plus a 4ab. Doesn't matter which way you go about it, you're going to get the answer. So let me put my plus 4ab over this side. So now I can say they're both equal to each other, however I'd have to plus a 4ab to the negative version. Now, I know that a plus b all squared is bigger than or equal to 0. I also know that a minus b all squared is bigger than or equal to 0. So if I take a minus b and I plus a value to both sides of that inequality, which once again, we know we can do this according to our inequality proofs. So I plus a 4ab and I plus a 4ab. That is my mistake. This should be a positive here. I'm wondering why it's not working out, but yes, that's just because I was supposed to have a plus in the question. Okay, so now I'm getting to this point here. Now I know that this left-hand side here, that is equal to a plus b all squared. And that comes directly from this line here. So therefore, a plus b all squared is greater than or equal to 4ab. And there's my proof done. It's just about playing around with them, looking at what's familiar and looking at where you know things are bigger than 0, and then using those inequality proofs of what we can add or what we can subtract to either side of our inequality. Okay, now given those two, let's have a go at some example questions. Let's say that we want to show that a4 plus b4 plus c4 plus d4 is bigger than or equal to 4a, b, c, d. And I'm going to add in that a, b, c, and d are all bigger than or equal to 0. All right, let's have a look at this. Straight away, I would be thinking about what this looks like. I'd think, okay, this reminds me a bit of that one we've already proved before, up here, that, let me just use x and y for the time being. X squared plus y squared is bigger than 2xy, or a squared plus b squared is bigger than or equal to 2ab. And I would say shown above. Okay, so knowing that, now you'll understand why I did x and y. If I let x equal a squared and y equal b squared, let's see what I get. I'd get a4 plus b4 is bigger than or equal to 2a squared b squared. So now I would do the exact same thing. I don't have to show it because I've already shown it once, but I could then assume the same thing for c4 plus d4 is bigger than or equal to 2c4 d4. Now, plus my inequalities together because I can do that according to my inequality laws that we looked at in class. I'm going to get that a4 plus b4 plus c4 plus d4 is bigger than or equal to 2a squared b squared plus 2c, these should be squares here, not powers of 4, c squared d squared. And I could even tell the marker that I'm using inequality addition to get that value. All right. Now I'm thinking about this, I say, okay, well I could factorize out a 2. And this is an interesting one. I know that x squared plus y squared is equal to 2xy. Or in other words, I know that it's greater than. Sorry, it is greater than or equal to 2xy. X squared plus y squared Now I know that x squared plus y squared is greater than or equal to 2xy. So I can make that substitution. Imagine me thinking about this as in x is equal to AB and y is equal to CD. Then x squared is equal to a squared b squared and y squared is equal to c squared d squared, which gives me that substitution in here that I can now say it's greater than or equal to 2 lots of 2xy or 2a squared b squared c squared d squared. No. I shouldn't have the squares. Because it's 2xy, not x squared y squared, sorry. Okay, so 2xy, and x is AB, y is CD, so I get A, B, C, D. There we go. Okay, I'm getting there. Which then gives me the value that they want, that is bigger than 4A, B, C, D. Okay. Next one, let's have a look at prove x squared minus xy plus y squared is bigger than or equal to xy. Alright, so straight away, I'm going to be thinking, what does this look familiar? How does this look familiar? It looks like this. And we know that's equal to x squared minus 2xy plus y squared. Okay. So therefore, we can then say that x squared minus xy plus y squared is really x minus y all squared. But to get them equal, I would have to plus an xy onto this one. So it would just become negative xy, which is what I'd want. So plus xy. So now I can say they're equal to each other as long as there's a plus xy on the end. Okay. Now, what do I know? I know that x minus y all squared is bigger than or equal to 0. So then I can say since then x minus y all squared plus an xy is bigger than or equal to 0 plus an xy. Again, using your addition inequality. So, okay, now I know that up here, according to this line here, that x minus y all squared plus xy is equal to that, which gives me x squared minus xy plus y squared is bigger than or equal to xy. And there's my proof. Okay, let's do one last one on these. It says factorize x cubed plus y cubed and show x cubed plus y cubed is greater than or equal to xyz on xz plus yz if x, y and z are bigger than 0, it says. Okay. First thing first, it asked me to do is factorize those cubes. Now, going back to advanced maths, on the formula sheet it tells us how to factorize cubes. Subbing straight into that formula, you should get this. Okay, so that's just using your formula sheet. Okay, now this is interesting. Up here I proved that this here was bigger than xy. So let's do that. let's state x squared minus xy plus y squared is bigger than or equal to xy, shown above. So then, therefore, now I want to make it look like this one here. To get it to look like this one, I need to use my multiplication identity that says I can multiply both sides, and the inequality still holds. So therefore, timesing by x plus y is greater than or equal to xy timesing by x plus y. And you think, I'm nearly there, but they didn't want xy timesing by x plus y, they wanted xyz timesing by x over z and y over z. But that's as simple as knowing that really, if you expanded the xyz out in that bracket, your z's would cancel, because timesing by z, dividing by z. So it's just a matter of writing that last line to suit what the question wanted. And once again, I'll just reiterate what I just said. It's because when you expand that, the z will cancel. So it is the same thing as this line above that we wrote here. Okay, all done. Hopefully that's given you a bit more insight into those questions. Have a go at your textbook work and email me if you need any help with those.